consider this image that's supposed to represent a Ferris wheel, and this is a bucket on the Ferris wheel or a seat in the Ferris wheel going around. And so we can animate this showing the passage of time. So here the bucket is going around. Now let's say that we were interested, and it goes around for 2 revolutions. Let's say we were interested in what is the height of the seat on the Ferris wheel over time. So let's go back to the beginning. If we want to focus just on the height, what we can do is walk around the Ferris wheel so that we're looking at it as if the people are coming at us instead of the side view of the people, where you often stand if you're looking at somebody on a Ferris wheel. So I'm going to leave it right about there, not dead on, but almost. Now what you see is the seat on the Ferris wheel just goes up and down and up and down. So all that we know is that it's gone up and down. If we want to know about the height of the seat on the Ferris wheel over time, what we need to do is, like we do again on a seismograph, is have a tracer and the paper moves to the left. So I'm going to do that, and now let's animate this. And that generates a sine wave. So very often in real life, things are going up and down and up and down. And we mathematicians think of them as a sine wave, but what's really happening is something is moving rectilinearly up and down, like waves in the ocean, for instance, or the head of a drum going up and down. And mathematicians then say over time, if you want the position of that object over time, it forms this curve where this is time and then this is the height. So trying to bring in the idea of sine and cosine of angles that are a multiple of 0, 90, 180, 270, 360. If we go back to the beginning, then what we can see is that so if this is the sine curve here, where this would be the sinusoidal axis and this is 1, this rotation here represents the sine of 90 degrees equals 1. You see, there's where we are there. And the sine of 180 is 0, the sine of 270 is -1, the sine of 360 is 0, and then we can continue if we want, second time around circle. Hopefully that'll give you an appreciation for where many real-world applications of sinusoidal waves come from, things that are moving rectilinearly, but if we trace it over time, then it makes a sine curve.